Good day everyone, we are the group 1 and for today's video, we will demonstrate to you the milk experiment. Now, we will start the experiment.
Prepare all the materials that the experiment needs such as milk, bowl, food coloring, cotton buds, and dishwashing liquid soap. And for the second step, just pour the milk on the bowl. For the third step, add a little amount of food coloring in the mixture and remember, don't mix it because the result of the experiment may fail.
Then in the fourth step, we must only dip the cotton to the mixture and don't pour the soap directly. Step 5, put the cotton bud to the mixture of milk and food color. And in the last step, observe what will happen.
Our experiment is all about polarity. In doing our experiment about polarity, we choose the colorful milk polarity experiment. To explain this experiment, basically it is the interaction between the milk and the soap. Because when we put the food coloring, nothing happens, it just stayed in the middle. But at the moment we drop the soap or we put the soap in it, it started getting away from the point that we put the soap. We didn't have to move the soap around, we just put it in the middle, and the milk continues to move away from the point that we put the soap. The milk is made mostly of water molecules, but it also has fat molecules and protein molecules, which are bigger than water molecules. Now the soap is made up of soap molecules. Now the moment that we put the cotton buds into the solution or in the milk, what happens is the soap starts to bond with those fats and proteins, and that causes the milk to start to move. The milk started to swirl because of the chemical reaction of the soap. Now milk and soap is bonding or it's actually connecting to the fat molecules and the proteins. Or in other term, when you first put the soap on the milk, the negative end of the soap molecules lined up with the positive end of the water molecules. This caused the soap molecules to zoom out in every direction over the surface of the milk and push the food coloring out toward the edge of the plate. The other reason that happens is that because the soap breaks down the surface tension of the milk. So if you are going to look on a glass of water or milk, what you can see at the top of the water or the milk is what you call surface. Those surface, we call it surface tension. The surface tension arises due to the cohesive interactions between the molecules and the liquid. Now the soap rapidly destroys the surface tension. That's because of the reaction that has been going on. The bonding that is going on between the fat molecules and the soap. So that too causes the milk to start to physically move. Overall, that is the reason why the milk started to move. The surface tension breaks and the fat and protein start bonding with the soap. That causes the milk to swirl. That would be all. Thank you.
Before I put the salt in the acetone acetator and also the water with food color, acetone and water dissolve well in one another due to the hydrogen bonding interaction between the oxygen atom on acetone molecule and the hydroxide bond on water molecules. Now, since we have already put the salt here, all four of these components mix very well together, acetone, water, blue glitter, and orange food color to form a green colored solution result. When a lot of table salt was added, like in the bottom part of the bottle, The green solution was separated into two layers. A blue-colored acetone-rich layer on top, and a yellow or orange-colored saltwater-rich layer on bottom. Now let's mix them together and see the magic. As you can see, it's starting to turn into orange, and here it's starting to turn into blue. And when the salt dissolves into the mixture, the resulting of the sodium chloride, ions interacted very strongly with water molecule through ion dipole forces. These ion dipole interactions attracted water molecules much more strongly than acetone-water-hydrogen bonds. As a result, the ion dipole forces pulled the water molecules away from the acetone molecules, and the liquid separated into two separate phases. The orange dye, or the orange food color, which dissolved better in water than in acetone, ended up in the saltwater layer. The blue glitter, which dissolved better in acetone, ended up in the acetone layer. Like this. And this is the result of our experiment today.
In a half cup of water, put 5 spoonfuls of vinegar and mix it up all together until it's well combined. And what a great job! It's a polar covalent bond. Oh, show us what you've got, boy. In a cup of water, put 5 spoonfuls of alcohol. Mix until it's well combined, and yes, it's polar bond. What a serious man we have here. In a cup of water, put 5 spoonfuls of vinegar and alcohol. Mix until it's well combined, and yes, it's a polar mixture. Hi Jerry, in your half cup of water, put 5 spoons of oil until it's not well combined because it's a non-polar mixture. What a lovely girl we have here. Okay, in your half cup of vinegar, put 5 spoonfuls of oil. Try to mix it. And John, no, it's a non-polar covalent bond. Thank you. Show us your setup, gorgeous. In an empty cup, put 5 spoons of alcohol and oil. Try to mix it until, yes, it will not mix together because it's a non-polar mixture.
The setup that mixed together are the setup 1, 3, and 5. Those are the polar setup. And the setup that did not mix together are the setup 2, 4, and 6, which we call the non-polar setup.
When atom combines together to form a molecule, the end of the molecule may have a positive and negative charge. As a result, the positive becomes polar and negative becomes nonpolar.
I think this polar and nonpolar activity experiment show how different liquid elements combine, but some of liquid molecules didn't combine at all. For example, we noticed that every setup that mixed with oil didn't mix to other liquid, and that is example of nonpolar. On the other hand, the liquid setups that mix to each other is called polar.
Why do you think it is impossible for oil to mix with other liquids? Water molecules are polar, and one end has a negative charge and a positive charge. Those charges let the molecules form hydrogen bonds and attach to each other molecules that are also polar. However, oil molecules are not polar and they can form hydrogen bonds. So if you put oil and water and other liquid in one container, the water molecule will bunch up together and the oil molecule will also bunch up together, forming two distinct layers.
That's all. I hope you learned something from the video, and see you again next time.
Intermolecular forces.
Hi everyone! Today is an experimenting day, so sit back, relax, and enjoy. But before we start, let's define first what is intermolecular forces.
Living life, every day, late at night, not okay. All I want, and I pray. All I need are some better days. Fuck me, I'm looking in the mirror, so foggy, but I've never seen clearer. I don't really think anyone can save me, and honestly I'm not really sure I want saving. I like to be my own worst enemy. There's no risk if you don't try at anything, so I'ma just keep buying everything. See you in the next life, have to be a better me. I don't think that my head's on straight, gotta flip it and grip it and go and get an x-ray. What's wrong with me? I just feel weight pushing on my chest and it squeezes till I suffocate. Better change my mindset, meditate. It's pretty cool that I'm alive and have better days. I could walk, see, hear, I should celebrate. Think I could change my mind, maybe elevate. Living life, everyday, late at night, not okay. All I want, and I pray, all I need are some better days. Yeah, all I need are some better days. Cause all I want, and I pray, I believe in the better days. I'm kinda stuck between a rock and a hard place. Do I work hard or live at my pace? You're only young once, yeah that's all great, but I also want a future where I'm okay. Living life is doing lots of cocaine. Wait no, it's living with no shame. Wait no, it's sleeping in on Sundays. I guess it's different for each of us and that's okay. Well I just wanna be happy, how to get there? Glad that you asked me. I think it's different for everyone. Some of us need work, others need fun. Some of us need purpose to overcome. But try to do what you love when it's said and done. Cause there's so many differences in each of us. Trust your gut, it can show you what you want. Living life, everyday, late at night, not okay. All I want, and I pray, all I need are some better days. Yeah, all I need are some better days. Cause all I want, and I pray, I believe in the better days. Living life, everyday, late at night, not okay. All I want.
Put our index finger in the middle of the bowl and let's see what will happen.
As you can see, the soup is able to move the pepper on the side, causing the unaffected water to have a higher tension than the water while carrying the pepper.
Surface tension exists due to the water molecules that stick together. The soap weakens the intermolecular forces of water, reducing the water surface tension.
Polarity experiment of group 1. So, now, let's start the experiment.
For setup number 1, put 1 cup of water and then add 5 tablespoons of vinegar.
For the setup 2, another 1 cup of water and 5 tablespoons of oil.
For setup 3, 1 cup of water and 5 tablespoons of alcohol.
For setup 4, put 1 cup of vinegar plus 5 tablespoons of oil.
For set 5, once again, put 1 cup of vinegar and 5 tablespoons of alcohol.
Lastly, another 5 tablespoons of oil plus another 5 tablespoons of alcohol.
We are going to use spoons to stir each mixture that we did earlier. And we are going to repeat the same process to the remaining sets.
In the experiment that we presented, setups 1, 3, and 5 are mixed well, while the rest did not, and those are setup 2, 4, and 6. While doing this activity, we observed that everything mixed with oil does not mix well, and it separated into the water and vinegar because polar substances are likely to dissolve in a polar solvent. Polar compounds do not dissolve in non-polar compounds. Water is a polar molecule, and vinegar and alcohol that were combined with different tests were both mixed well together, indicating that vinegar and alcohol are polar compounds, but on the other hand, oil is non-polar.